Hello everyone, how are you? I hope you're in a great condition today.
We are from A-Level class, Group 2 Physics video project in Karisma Bangsa High School. Our group consists of 3 members. I am Ariel.
I am Melissa.
I am Farah. Today, we are going to discuss 2 topics. First is about displacement time graph, and second, combining displacements.
Hope you guys enjoy it. First, we are going to talk about displacement time graph. There are 3 components of displacement time graph. They are displacement, time, and x and y axis graph. Look at this graph. The straight line shows that the object's velocity is constant. Next, the slope shows which object is moving faster. The steeper the slope, the greater the velocity. So we can see that this slope is steeper than the other one, so this slope has higher velocity than the second one. The slope of this graph is 0. The displacement is not changing. The velocity also 0. And we can say that the object is stationary. It's not moving at the moment. The slope from this graph suddenly becomes negative. The object is moving back the way it came, so its velocity is negative too after time t. Next, in this graph, the displacement time graph is curved, which means that the object isn't moving with a constant speed or accelerating. Here are some steps to draw displacement time graph. First, measure an object displacement and time needed to cover it. Second, plot it in a table. And third, make dots representing the data and draw the line. Let's look at some questions. This is displacement time graph for a toy car. And question is calculate velocity in A. So it is asked to calculate the velocity in this A line. Stop this video, pause this video if you want to try to solve it by yourself first before we discuss it. Okay, so the solution is, first we need to recall what is a velocity. Velocity formula is change in displacement over time taken. So it is delta S over delta T. In A line, the delta S is from this point to this point. So this is about 1 and this is about 7. So we can put it 7 minus 1, and the delta T is 3 minus 0. So 7 minus 1 is 6 and 3 minus 0 is 3. So 6 divided by 3 is 2. So the velocity in this question is 2 meters over second.
Okay, let me continue. Here is the second problem. You are given a table containing displacement depends on time. So, what is the velocity of the car during the speed trial? You can skip this video if you want to solve it. Okay, if you have done, let me show you the solution. Before we try to solve the type of question, we should know, of course, the formula of velocity, which is displacement or change in displacement divided by time taken. In the table, final distance and time taken are respectively 340 meters and 4 seconds, and both displacement and time taken started from 0 point. Thus, we just need to divide 340 by 4, which is, the result is 85 meters per second. It's easy, right? Move forward. we are entering a new subchapter, which is combining displacement. In this subchapter, we are going to learn how to find a final displacement if you are given two displacements at the same time, and moreover, two of those have different direction. Let me give you an example of it. Here, I have a map showing a track from Indonesia's national monument to House of Representatives building. Blue line indicates distance, which is a scalar unit, and straight red line denotes actual displacement, which is a vector unit. Because displacement is a vector unit, we can't draw it with some curves and junction like rail track or blue lines. Instead, we should draw straight lines connecting initial and last point. But what we actually need to find actual displacement if we are provided two or more displacement? We can use two concepts. Those are geometry and trigonometry. So, how to find actual or final displacement using those two? First concept I want to show you is geometry. We can use Pythagoras theorem to find final displacement. First thing we've got to do is to draw a straight line connecting first, which is this point, and the end point, like this red line. Then, we can solve this problem using Pythagoras theorem by inserting green line and blue line value. So, we just take 6 square plus 9 square, and we got square root 117 as the answer. As simple as that. Or, on the other hand, the basic formula is green line square plus blue line square is equal to red line square. Second concept is trigonometry, or sinus, cosines, and tangent rule. The formula of those three are obviously different. Theta is an angle between adjacent and hypotenuse, in case if you don't know it yet. Sin theta is equal to opposite divided by hypotenuse. Cosine theta is equal to adjacent divided by hypotenuse, and tangent theta is equal to opposite divided by adjacent. Trigonometry concept includes cosine rule. It's a bit straightforward. On this example, lines are indicated with lowercase letters and angles are indicated by capital letters. So, the formula are a square is equal to b square plus c square minus 2 times b times c times co-angle a, and b square is equal to a square plus c square minus 2 times a times c times cos angle b, and c square is equal to a square plus b square minus 2 times a times b times cos angle c.
Now, let's go to the question's example of combining displacement. An ant walked 11 centimeters to southeast and 7 centimeters to east. Calculate the final displacement of the ant. There are two ways to solve this problem. The first solution is using the scale drawing, where you need to do is draw two proportional lines and connect first and last points of the line. As you can see, we can measure it by the ruler and find the resultant, which is 16.7 centimeters. The other way to solve this problem is using cosine rule, where you need to do is find an angle between first and second line. After that, you need to use cosine rule to get the resultant. As you can see from the slide, which shows us the picture and the way to solve this question, using cosine rule, we still get the same result as the previous one. In this case, 16.7 centimeters. The other example question is, A spider runs along two sides of a table. Calculate its final displacement. This picture shows us how the spider moves. There are two steps to answer the question. First of all, since the two sections of the spider's run are at right angles, we are able to add the two displacements by using Pythagoras' theorem as shown below. Thus, the result is 1.44 meters, or we can write 1.4 meters. The next step is we need to find its direction using tangent ratios. After we find that, it says that the angle shows us 33.7 degrees or 34 degrees north of east. So the answer will be the spider's displacement is 1.4 meters at 56 degrees or n 56 degrees e or at an angle of 34 degrees north of east. Now, let's move to the last example of the question. An aircraft flies 30 kilometers due east and then 50 kilometers northeast. Calculate the final displacement of the aircraft. Here, the question also provides you with a picture which can help you to understand the question. Again, there are several steps to answer this question. Firstly, you need to choose the suitable scale for your diagram. Here, the picture provides us the scale of 1 cm that represent 5 kilometers. As you need to know, the two displacements here are not at 90 degrees to one another. So, we cannot use Pythagoras' theorem. But, we can solve this problem by making the scale drawing and measuring the final displacement. So, let's move to the next step. After you choose the scale, you need to draw a line to represent the first vector. North is at the top of the page. In this picture, the line is 6 centimeters long. Based on the scale, it is 30 kilometers towards the east. After that, you need to draw a line to represent the second vector, starting at the end of the first vector. Here, the line is 10 centimeters long and at an angle of 45 degrees. As an information, the 10 centimeters in the pictures represent as the 50 kilometers, based on the scale. To find the final displacement, you need to join the line from the start to the finish. From that, you have already created a vector triangle. After that, measure this displacement vector and use the scale to convert back to kilometers. From the picture, we can find that the length of the vector is 14.8 centimeters. Thus, the final displacement is 74 kilometers. The last step that we need to do is measure the angle of the final displacement vector. From the measurements, we can find that the angle is 28 degrees north of east. Therefore, the aircraft's final displacement is 74 kilometers at 28 degrees north of east, 62 degrees, or n 62 degrees e.
Since we have learned from the first topic and the second topic, we will now move to the end of the slide. Thank you for listening.
Thank you for watching.
Thank you for staying with us until the end. Have a good day.